as well. Okay, I start recording and I want to share the lab manual. Okay. Is there any other questions while I'm explaining the theory? That way I can mention your questions as well. Okay. Good. The extraction that we are talking about in this experiment is known as the solid liquid extraction, or we could have like a liquid extraction. What's happening in extraction, just going to go to the equipment that you are using in the lab for the extraction. The equipment used in the lab for extraction is separator funnel. This is the device that is used for extraction. The diagram, or figure 4-1, it shows the separator funnel setup and uses, like how to use it, like how to vent or release the pressure, basically. When you looking at this diagram, it shows that you have two layers. Okay, you have two layers. So when you are performing the experiment, at the beginning you have to bring the mixture of the components, because extraction can be used for two purposes. One is the separation. So let's say you have a mixture of two compounds and you want to separate them. That's basically what you are doing in this experiment. And then the other experiment, or for another experiment, let's say you have a chemical reaction. I'm going to give you example of chemical reaction. Let's say you have benzoic acid and methanol. You mix it. You add sulfuric acid as the catalyst. The product is going to be you're going to have two products. One is methyl benzoate and one is water. We don't need all the mixture together as a product. We only want methyl benzoate as the product. So to remove that single product from that mixture that you have at the end of the experiment, end of the reaction, you basically extract that compound out of the impurities, leftover reactants, the byproducts. If you have two products, minor product, major product, you want only one product. So you take only one product and you extract into a proper solvent, which we are going to talk about. Proper solvent. What is a proper solvent here? So if you have a mixture of two compounds, you dissolve that first in the in an organic layer, in an ether layer, because it's organic compound. So you pick a solvent that would dissolve both of them. Okay, you take one. In this example, in this experiment, we are using ether. Ether would dissolve both compounds. Your compounds must be different in the acidity, because this is an acid-base extraction. So one compound could be neutral, the other one acid. Another scenario, one compound could be neutral, the other one base. Another one compound acid, one compound base. Or you could have a mixture of any sort, with the condition that the two compounds cannot have same functional group, or you cannot have two acids. If you have two acids, you cannot separate by extraction, because whatever you do to one acid, the same thing will happen to the other acid. Then you are adding a reagent to bring one of these compounds to make it more soluble in the aqueous layer, and you pull it into the aqueous layer. Then you separate by opening the stop group. The steps when you have your compounds or the mixture in the solution is to add a reagent or solvent that will react with one of them. Right after adding, you have to shake it. You have to close the stopper, the glass stopper, and shake it. When you are shaking, that's the part B. It shows how you hold it when you are shaking with 2 hands, and then you open the stopcock in order to release the pressure. The solvent that is used in this experiment is ether, diethyl ether. So when you shake it, you give some energy, it evaporates, it builds up lots of pressure. Sometimes there's a reaction that produces carbon dioxide or other gases or vapor of the solvent in general, and it produces a lot of pressure. So you have to release it, release the pressure periodically so it doesn't cause any, it doesn't explode, or it doesn't splash, or it doesn't make the stopper to jump or to move or be, you know, moved out of the place. So you have to shake it, vent it, release the pressure, and then you place it back on the iron ring, which is the setup. Proper size depends on the size of the separator funnel. You take the cap off. Why do you have to take cap off before you open the stopcock? Because if you leave the cap on, it's going to build vacuum there, and when you open this, the liquid doesn't come out. You might see drop coming out, but that's not what you want. You want to separate the 2 layers smoothly. So you want to make sure the cap is off, and you have to remove it when you are draining, and you allow the air to come in from the top and the liquid dispense from the bottom. And you would stop when you still have like 1 drop of the bottom layer. You don't want to bring the top layer and mix it from the separator funnel into flask and mix it. So in general, that's how the extraction is done, and some of the conditions that I told you. Let me take you to this diagram. In the diagram like this, we have another diagram also, which I'm going to show you both. In this diagram, what you have to begin with, say you have a solvent that could be ether. Ether is a good solvent, and the characteristic for solvent is given in the ebook. So I'm sure you will, go back and read it if you have not, and you will get that characteristic. What should be the proper solvent? But definitely, it should dissolve both of the components. Let's say you have a carboxylic acid. This is an organic acid, and ether is polar enough to dissolve this. And then R3N is amine. Amine is a base. So it's not neutral, is a base. So you have acid and base. Both of them dissolved in ether. Now, you have to add the reagent. In this case, you are adding sodium hydroxide as a reagent to react with the benzoic acid and brings the benzoic acid into aqueous layer. Why does benzoic acid react with sodium hydroxide? Because it's acid and base reaction. And what would be the product? The product is going to be a sodium benzoate. Is this compound ionic or molecular compound? Sodium benzoate, is it ionic or molecular compound? It's ionic, right? And we learned from general chemistry that if you have ionic compound, or your compound in general contains sodium, is going to dissolve in water, a soluble compound. So this compound is going to dissolve in aqueous solution, and it comes down, the compound, the benzoic acid, it separates from the organic, from the ether, and it comes into the aqueous layer. So you would have that in the aqueous soluble salt format of sodium benzoate in the aqueous layer. And that's not what we want. We don't want the aqueous layer. We don't want a liquid to recover it, because our benzoic acid, it used to be solid at room temperature. So we are going to, if you add HCl, HCl reacts with sodium benzoate, is going to remove sodium and bring back hydrogen. Sodium goes with Cl, so you will get the benzoic acid. Benzoic acid does not dissolve in water at room temperature. And we saw that in experiment 1, benzoic acid did not dissolve in water at room temperature. So you will see that precipitate, and when you see that precipitate, you collect. The organic layer that you have now contains base and solvent, ether layer that contains base. Now to this ether layer, if you add HCl, HCl is acid, amine is a base, and you are going to mix this to acid-base reaction. You get a salt. Again, there's the plus minus charge here is another ionic compound that dissolves in aqueous layer. So it will come to the aqueous layer, is in form of the salt. Now to this solution, because you separate it, but you now have to recover it. If you add sodium hydroxide, it would remove the Cl, and you're going to gain back and remove the H plus basically is removed from the salt. And when you remove the H plus, you are going to end up with R3N, or recover the base. If you want to recover the base from the salt of the base, you add a strong base. So when you add a strong base, it's going to change it to the original compound, and then it's not, because it's not soluble in water, you are going to separate it. And okay. So if you have a neutral compound of RH, with a neutral compound of RH, you have, which is left now, you remove the acid, you remove the base, and now the only thing that is mixed there is what is left is the neutral compound. The neutral compound stays in the ether layer. So you separate the acid by adding sodium hydroxide, you separate the base by adding HCl, and the neutral compound would stay in the ether layer. So your ether layer, if you evaporate the ether, you end up with a neutral compound. So this diagram, it shows 3 component, mixture of 3. To remove acid, you're adding sodium hydroxide. To remove base, you're adding HCl, and the neutral compound is going to stay in the organic layer. Now, the experiment you are doing today has 2 compounds only. And the 2 compounds you have, one is benzoic acid, and the other one is dimethoxybenzene, which is considered a neutral compound. It's not a base, it's a neutral compound, and you have the acid. You are dissolving in the ether. This is known as, is already labeled as solvent. So when you dissolve this in solvent, everything is going to dissolve in ether. Both of them is going to dissolve in ether. Then what is next step? You're adding sodium hydroxide. When you add sodium hydroxide, is going to react with which one? The neutral compound or the acid? You add sodium hydroxide. It's going to react with the acid. The acid goes to the aqueous layer. The neutral compound is going to stay in the organic layer. It says that some trace amount of the acid could be, when it says trace, that means most of it is gone to the aqueous layer, but trace amount is, or it could be left over. To make sure to remove the rest of the benzoic acid, you're adding another portion of sodium hydroxide. This time, when you add another portion of sodium hydroxide, whatever of benzoic acid that is left is going to go to aqueous layer, and you combine these 2 together. Okay, you combine these 2 together. Then, organic layer, your ether layer that has some water and drops of water, and the ether and this, you are going to remove the drops of water using sodium sulfate. Then you are going to evaporate the ether, and when you evaporate the ether, you end up with this only, and that's what we want. On the other side, when you have when you have collected all the sodium benzoate from aqueous layers in 2 or 3 steps, then you are going to add HCl to change the sodium benzoate to benzoic acid as a solid compound, vacuum filter it, and recover the solid compound. So that's the diagram that is going to, this diagram is showing you how to separate and recover both acid and neutral compound, which is the experiment you are doing today. Which solvent is going to work the best? A solvent that is going to have a significantly different solubility for one compound versus the other compound. So at the beginning, both of them dissolves in ether, but after you add sodium hydroxide, when you add sodium hydroxide, benzoic acid would react with sodium hydroxide and you get benzoate. Now, benzoate is not soluble in ether. And because it's not soluble in ether, or the solubility of benzoic acid is sodium benzoate is much higher, few times more in water than the ether, then is going to be extracted into the aqueous layer. But this compound, methoxybenzene, dimethoxybenzene, it's maybe 10 times more soluble in ether than water, so that stays in the ether layer or organic layer. And that brings the concept of KD. What is KD? KD is distribution factor or partition coefficient or distribution factor, which is the ratio, of solubility of the compound. So it's a partition coefficient, yes, it's a partition coefficient, which shows the solubility of a single compound in ether layer versus the water or aqueous layer. It should be like the ether layer versus the aqueous layer. You would always use water as the aqueous layer. And what should be your solvent for the organic layer? What's one of the conditions? There are like plenty. Can you each say one of them? What's the condition for proper extracting solvent? What are the conditions? You can type it. There are plenty of them, and each one of you can say one. Different acidity, no, that different acidity is the other compound. When it comes to solvent, choosing of the solvent, it doesn't have to be acidic or basic. We're not talking about the reagent, we're talking about organic solvent. Doesn't react with the solute, so it should not chemically react. It should be easy to separate. You don't want it to react because it has to be easily separated later. What else? Like in this case, ether is the extracting solvent. You have the aqueous layer and you have the ether layer. What are the characteristics for ether that is good solvent for extraction? Different density, very good. Must have different density because in the separatory funnel, you want to see the separation. You want to see the two layers, organic layer and the aqueous layer. Boiling point should be low because at the end, when you evaporate the ether or the solvent to recover the neutral compound, if it has high boiling point, is going to cause decomposition of the organic compound. So we want to make sure that the boiling point is low. Insoluble in, okay, it should be insoluble in aqueous layer. It should be insoluble in water. So it cannot be miscible. Miscibility with water is a condition, and it must be immiscible. Because if the organic layer or the ether layer, we're talking about the solvents only, not the compounds. If the solvents are miscible in each other, you're not going to get two layers. You would get only one layer, and that is not extraction. In extraction, you must have two layers. So the most important characteristic for extracting solvent is that it must be immiscible in water. That's the first condition. And then it has to have low boiling point. It should be able to dissolve both neutral compound, acidic, and basic compounds. So it should have some polarity, but it cannot be too polar. And the expense is always a concern. Yes. Has to have low boiling point, so your recovery is going to be faster, and you don't want it too high. Extraction solvent should have a favorable distribution coefficient for the compound being extracted. Very good, and it should be safe. When you say favorable solubility or distribution, you're talking about KD value. The higher the KD value, the better the solvent is. So what does this 11.25 means? It means that this compound is 11 times more soluble in ether than water. So that's a good sign, right? That is a very good sign, because your compound is going to stay in the ether layer. It's more soluble in ether than water. So you're not going to lose most of the compound or significant amounts of that compound to the aqueous layer. So KD, or the distribution factor or distribution coefficient, is one of the characteristic but is a technical term. So I don't want to say that it must have high KD. Then the question is, what is KD? So when it is explained that it should selectively dissolve one compound and not the other. So your solvent must, your solute must be more soluble in the solvent compared to the aqueous layer. This shows the high KD value. Or the other, if you're talking about the other compound, it's going to be the opposite. It should be more soluble in water than ether. So it should go to the aqueous layer. If the value for KD is given, you should be able to calculate the gram that it goes into ether layer and the gram that it goes to the water layer. You can calculate that, or whatever is going to stay in the water level layer. So to calculate that, if the solubility is given in ether, solubility is given in the aqueous solution, you can calculate KD. But if the KD value is given, you can find out how much is going to be dissolved. It's going to dissolve like in the solvent that you're adding. So you can find that value to say how much is going to dissolve. So about 92% is going to go to the ether layer. So 92%, that's a lot of, that's a good value for KD. That says that this solvent can separate. The other point that I want to explain before I start asking you guys questions is the fact that we are doing this experiment multiple times, the extraction multiple times. We add 10 milliliter of the sodium hydroxide, and then we add another 10 milliliter of the sodium hydroxide. So we add one portion here and one portion here, at least two. It doesn't hurt to add 3 times, but the condition is that each time you have to separate the 2 layers, collected. Okay, each time you have to see these boxes formed here. That means that you have separated. Now you're going to combine it. So you cannot keep adding sodium hydroxide to the same funnel that you already had sodium hydroxide. You have to add the solvent, you shake it, you release the pressure, and then place it in the iron ring, separate the 2 layers. Then you add the next portion of the same solvent. Let's say if the example is that the compound is going to be 90% soluble in the sodium hydroxide. So when you add the sodium hydroxide, you're going to extract 90% of that only. What happens to the other 10% is going to stay in the organic layer. as a trace amount. You add the second portion of sodium hydroxide, is going to remove 90% of the 10% that is left. That's basically 9%. Then you are going to remove a third portion. If you do the extraction 3 times, you take 90% of the 1% that is left, that is the 0.9%. So when you combine the 3 aliquot or the extract, that is going to add up to 99.9%, and that is a good recovery. But if you add 30 milliliters of sodium hydroxide once into the ether layer and extract it, instead of adding 10 milliliter, 10 milliliter, 10 milliliter, is going to remove 90%, and the other 10% is going to stay. So this action that you are adding the solvent, separating, adding solvent, separating before you add the next solvent is known as consecutive extraction. Consecutive extraction is done for more efficient extraction, and what it means that instead of adding 20 milliliter of sodium hydroxide at once, you add 10 milliliter, you separate, then you add another 10 milliliter, you separate. But that's about the consecutive extraction. And it has to be done. The purpose of using sodium hydroxide here to remove water from the ether layer. Okay, let me go to the chat room to look at your questions. I am kind of done with the explanation about the theory, but I want to answer your questions. Then I asked you questions. Is there a possibility of adding too little solvent and solvent being oversaturated and not extracting all of the compounds? Yes. When doing consecutive extraction, yes. So you don't use like 5 milliliters of sodium hydroxide. So if you're using, so that comes with the experience of the person who's designing basically the experiment. And at this point, it would be really, nice to do a research to find out what is the maximum recovery for extraction of benzoic acid if you choose like 3 10 milliliters instead of the 2 10 milliliters, or using 3 5 milliliters instead of 3 10 milliliters. And that, yeah, it is right. If it gets saturated, it's not going to bring in anymore. It doesn't, not saturated. If your solvent is limiting reactant, then it's not going to react. If your reagent, which is sodium hydroxide, is limiting reactant, it will finish, and then you would have more leftover of benzoic acid in this case and in general. Yes, that is true. So for consecutive extraction, you have to pay attention to the milliliter of the solvent that you are using as well. Yes, it's true. Yes, you want to add not the minimum, but proper amount of solvent for each of the consecutive extraction in order to collect maximum, in order to have maximum recovery of the acid, or the benzoic acid in this case. Very good. Any other questions? Questions? No questions? Okay. Okay, perfect. So if you don't have questions, I'm just going to go to the procedure for the experiment. And in this experiment, we are using 2 compounds. One is dimethoxybenzene, which is our neutral compound, and we have the benzoic acid. Steps in the experiment. So this diagram, it shows the general steps in this experiment. So you are going to set up the separator funnel using the iron ring proper size, so the separator funnel doesn't fall through. You want to weigh 1 gram of the dimethoxybenzene benzoic acid mixture. This mixture is not a homogeneous mixture. You will, if you look carefully, you might see that, you know, the sizes of the methoxybenzene are large. The size of the other one, the benzoic acid, the crystal size are large, and is not homogeneous mixture. It's not uniform. So when you take the one gram of sample, you might get 50-50, you might get like 40-60, but that makes the difference in percent recovery. Today, you're not doing, for this experiment, you don't do percent yield because it's not a reaction. It's percent recovery. We already know we started with 1 gram and we want to know how much of that is going to be recovered. So the safe way to calculate percent recovery, which is the amount recovered from the 2 compounds, is when you recover at the end, add the value for both of them. Let's say if one is 0.5 grams and the other one is 0.45 grams, you add the 2 together and divide by 1 gram times 100. That gives you the percent recovery. Or you find like 0.6 for one and 0.35 for the other one, is going to be the same thing. You have 95% recovery. So it's not the, I mean, the perfect situation would have been to have like homogenized and change it to powder and then take the 1 milliliter, 1 gram. But the purpose that I did not do that in that experiment is to show you that yes, we are dealing with the 2 compounds to begin with, and then we recover the 2 compounds. So it could have, you know, different benefits to it. So I have to explain, if you get like more than 0.5 for one and less than 0.5 for the other one, it is possible because your original sample was not perfect 50-50% mixture. Okay, you are going to dissolve it with the 50 milliliter of diethyl ether. And then step 4 is asking at 5 additional milliliter of the ether. What's the purpose of using that 5 additional milliliter? Can't I just use the 15 or use the 20 to begin with? Why am I transferring and then adding 5 additional? Be sure that all of the benzoic acid and dimethoxy dissolves. Any other explanation? To get rid of trace amounts? To get rid of, what do you mean to get rid of trace amounts? Because the explanation is step 4, it says that you are using this 5 milliliters to rinse the Erlenmeyer flask. The 5 additional milliliter. It says to rinse it. What does it mean to rinse it? Not in this case. Even 50 milliliter could dissolve it, but when you transfer from flask into separator funnel, some of it is going to be left over. So when you are rinsing, it's not that you're rinsing and you're washing and you're discarding down the drain or solid waste container. You are rinsing because this is for complete transfer. Okay, complete transfer to making sure that everything is to get the remaining residue. Okay, that's good way of saying it. To get the remaining residue and transferring the remaining residue into the separatory funnel. So just to make sure that we all know why we are using another 5 milliliters here. Then you're adding 10 milliliter of the sodium hydroxide. And what are the steps after that? When you add the 10 milliliter sodium hydroxide, what would you do? What's next step before you separate it? You have to shake the separatory funnel, vent the separatory funnel to get rid of to release the pressure, and then separate it. Okay, shake it, vent it, and separate it. And separate before you add the next portion of the 10 milliliter. Now, what's the purpose of using the additional 10 milliliter here? Of the sodium hydroxide. This is the case that you want to collect all trace amount of benzoic acid, to get the trace amount of the benzoic acid. Yes, the remaining amount of the benzoic acid. Yes. Then you are going to collect that in a flask. You are going to wash the ether layer with water. Basically, you add water, you drain the water. It's the same thing as washing the ether layer with water, because you want to collect any leftover sodium hydroxide, anything that is in the soluble compounds in the ether layer. Then you are going to collect those, collect the aqueous layer, which contains the benzoate, and you add HCl to that to get the crystals. Because when you add HCl, it gives the hydrogen back to benzoate. You get benzoic acid at room temperature. It's not soluble and starts forming the precipitate. To the ether layer, you are adding sodium sulfate. What's the purpose of adding sodium sulfate again? To dry the solvent, to dry the ether layer. Drying meaning removing traces of water or drying out any water that is left in the organic layer. What happens if you have water in there? The boiling point on the next step, you need to evaporate the ether to end up with the neutral compound only. Ether evaporates at 36 degrees Celsius, or in the fume hood, it would evaporate on its own without even boiling. But water boils at 100 degrees Celsius. Yes, the water, if there is any water left in the liquid, then when you are evaporating the ether, evaporating the ether, the water will stay and you cannot dry your product, and is going to give you false. By false is going to give higher mass. At the same time, it's not going to your sample is not pure and is going to affect the melting point. So higher mass and also melting point would be off, or melting point would be affected. So you don't want to. Yes. Okay, so you would remove the trace amount of water from that liquid and then evaporate the ether, and you end up with the organic neutral compound. To the other flask that you had your aqueous layer, you want to add HCl, and when you add HCl, you want to test it with the pH paper. What's the purpose of testing with the pH paper after adding HCl? Because it says add 10 milliliter of 3 molar HCl and test for pH. To make sure it's acidic, because if the solution is not acidic, benzoic acid will not form completely, and benzoic acid is not going to form. If the solution is basic, it's going to stay in benzoate form. If it's acidic, it goes to benzoic acid. Benzoate is soluble, so you cannot do anything to change it to the precipitate or crystals. You cannot crystallize it. It would only crystallize if it's in acidic solution. So that's why you have to test the pH. And after it's acidic, you are going to cool it down to room temperature. It's already at room temperature. You place in ice for 5 to 10 minutes. What's the purpose of placing in ice? That mixture is going to stay in ice. What's the purpose for that? You add HCl to make it acidic, allow crystals to form, precipitate benzoic acid, but oversaturating at low temperature. Okay, so this is going to help you with the maximum recovery of benzoic acid, because at lower temperature, more crystals is going to form because the solubility is lower. So we take that from last week's experiment. In last week's experiment, which was recrystallization, we should have the saturated solution, but temperature also needs to be low, and that's why we are using the ice bath. Then you are going to do the vacuum filtration and wash it with cold water, and after that you're going to dry it in the oven. 100 degree is good enough for 5 minutes. We want to make sure that the water is evaporated in this case, but the benzoic acid melts at 122. So if the oven is set at 100, you should be fine. That you are not going to lose the product, because the product doesn't melt at that temperature. The product melts if the temperature goes over 120. And then you want to measure the mass of crystals. When you measure the mass of crystals, you calculate percent recovery in this case, and also melting point for the compound. The literature value melting point, if you have it already in this experiment, fine. If not, you can Google it and find the literature value for the two compounds. And then for the total recovery, it says here the total recovery is not the percent recovery here. Total recovery is from the original mixture. You start with the 1 gram, you add the mass for the two together, and if it's you divide that by 1 times 100%, that gives you percent recovery. Okay, this experiment, extraction, and you probably noticed before I say it, it does require a lot, it does require more explanation because it involves some actual chemistry. It's not just separation. And it's the first time you're doing the extraction. So that's why I wanted to also, to answer your questions, I also wanted to explain more about the theory, how it works. Hopefully you learn this well and pay attention. When you are watching this video, pretend that you are in class, because I was teaching a class when I record this. Okay, my internet went back and forth, so I'm going to turn on the hotspot on my device to make sure it doesn't go. Okay. So when you are watching the video, pretend you are in the class, and as I'm asking questions, try to answer it. It might sound like funny, but that's the better way, that you have some better feeling that you're part of this class, you're part of the performing of the experiment as a group, and you try to answer the questions while you are or find out why we are doing each step the way that is done, to make sure you have better understanding of the experiment. Because anytime there is a chemical reaction and you have to extract only one of them, that is a solid compound especially, or a liquid that is highly soluble in one specific solvent and the rest of the compounds are not, then you would use extraction. And we just did experiment 12 in organic 2, and we used extraction there. So organic 2 also, anytime you do perform experiment that requires purification, one of the technique is extraction, one is recrystallization and distillation. But I must say, in most of the reactions, extraction is the first. Second is recrystallization in terms of the application or usage of it, percent use. But the other one, distillation only if your product is liquid and has a different boiling point compared to its impurity. Distillation would be used. Okay, do you have any questions? I know it took longer this time for my explanation. I don't have time to ask too many questions from you, but we did go over the procedure. I want to answer your questions if you have any more questions. Take attendance, so this way you can actually, you have enough time to watch the video and collect your data. The data table, it depends on the procedure and whatever is asking you to measure. So there is no set table for it. That was a question from organic too, but I just thought maybe, you know, I also explain it to you. Tarek, attendance. Ashley. Dua. Okay, Dua is at, I'm sorry, she's at 3:30 class today. Deja. Thank you. Rosie. Rosie, are you here? Rosie, absent. Okay. Ashana. Elizabeth. I'm sorry. Phone from publisher. Jennifer. Thank you. Alexis. Kylie. Colette. Colette. Are you here? No. Okay. Valentino. Danielle. Valentino, I thought you're here. Okay. Danielle. Mariah. Thank you. Gitania. Gitania, absent. Gitania's absent. Anifal. Anam. Sammy. Cassandra. Craig. Thank you. And Antonia. Antonio, you were not absent last class, were you? Were you absent last class? Okay. If you were absent, if you miss a class, just to let you know, that 3:30 p.m. is we are doing the same experiment, and because we are doing the same experiment, if you send me an email before 3:30, not at 3:35, please, because I got an email from Elizabeth at 3:35 last week, and since when I start the class, I can't go back and forth and check the I did get Tanya, but I actually marked you absent because you didn't respond. So, okay, I got you. So please send me email before 3:30. Beginning of this class, I don't know if you noticed or not, I actually went back and I checked the email to make sure if anybody is asking for access to attend this class. So I want to make sure that I give the same opportunity to your class. In case you missed the class and you could attend at 3:30, send me email before 3:30. You won't be able to access it unless I email you the link from the announcement. So you can do that. Just that's an option. Do you have any questions for the experiment? Because if you don't have questions, I'm going to stop the recording at this point, and I'm going to be here still to answer you any questions or concerns you have. But if it's about the experiment, I like it to be recorded just in case someone else has the same question later. Okay, not about the experiment. Then I'm going to. Your question is not about the experiment. I'm going to stop.